the ground shake.
Hello everyone, welcome to a new video. Today we'll be applying Dijkstra's algorithm to a directed weighted graph. And let's start at A. If we basically start at A, we have everything set as infinity. We can't really reach any other thing. And let's figure out, starting at A, where can we actually get to from A. So we can get to B for 25. That's better than infinity. So we are going to erase the infinity and have 25 coming from A instead. So that's the cost of traveling from A to B. We have another road to take, which takes us to B, costing 85. So we're going to raise the infinity and write in the 85 from A instead. And we can get to G for 105. So we again are going to raise the infinity and write a 105 coming from the source A. Since we have nothing else to get to from A, since we finished the three arrows coming out of A to other nodes, we'll begin with the shortest path, which is B. So we are going to take this, travel across this path, which is the shortest one, and right now we will visit B and start running the algorithm from B to every other node we can get to from B. So now we are going to start from B, knowing that we can get to B with 25 from A. Now we can get to F from 15. We can get to F with 15 from B. So that would be 15 from B. And since we can get to nothing else, we just copy down the values again. So 85 from A, 105 from A, and a bunch of infinities, since we cannot see the other nodes from B nor A. So right now we'll choose the shortest path, which is F. So right now we will visit F and start visiting other nodes from F. The nodes we can visit from F, as you can see, are C and D. Pretty much nothing else. So let's update the C and D on our table. C, we can get to C using 15 points from F, and we can get to D using 40 points from F. So we got to F, like the total cost to get to F is pretty much 15 plus 25. Since to get to F using this path, I have to pay 25 to get to D and pay another 15 to get to F. So that would be 25 plus 15, which is equal to 40. However, to get from F to D, it would cost me another 40. So that is going to be 80. Is 80 better than 85? Absolutely. So I'll update it and have it as 80 coming from F. Again, think of this as points being spent on like a tall road or something, like a tall highway, like the 407 or something. And you're paying 40 points to travel from F to D. However, remember, to get to F, you actually paid 15 and 25 from your own source. So this road costed you around 40, while this road costed you 85. Of course, the one with the lower cost is the 80. So we are going to rewrite this and like we'll overwrite the cost to 80 instead of 85, and we'll update the source from A to F. So pretty much we updated C and D. We'll copy down the rest because it's still unchanged. We visited B, we visited B, we visited F, and the rest are infinity since, oh my god, this is 105A. I'm just copying down the values previously acquired into the new row in our table, and I'll grab the lowest cost that will take me from F to the next node, which is 15, and that will take me to C. So right now I'll visit C and start running the algorithm one more time from C. So we're currently at C. We can get to H 20. 20 is way better than infinity, so we will overwrite infinity to 20 coming from C. We can also visit F with 60. However, I can already visit F with 40 instead of 40 plus 15 plus 60. So visiting F through C would be much more expensive than just visiting it from D. I hope that's clear. So I'm not going to update this. I'll just copy down the previous value since it's better. And remember, we visited that node. And we can get to pretty much, oh yeah, we can actually get to D using 55 points. So we can get to D with 55 from C. So, do you think this is better than 80 from F? Actually, that's not 80 from F, that was 40 from F. I'm sorry, that's a typo. So, if I got to C using 25, 15, and 15, is it better to spend 55 from C to D, or should I just spend 40 from F to D? Of course, since they both begin at F, F would cost me 15 and 55 to get through C and then D, and it will cost me 40 to get directly from F to D. So of course, the new path is more expensive, and it's pretty much useless. I'll not add it to my graph, since they got a shorter path. So I'll just copy it down. We can get to E from F using 40 points, and that's pretty much the best deal we got till now. So I'll just keep it as it is. I'll not overwrite anything, since the new road I discovered is more expensive. We can visit no more nodes from C, so I'll just copy down the values we previously acquired from other nodes. Remember, we visited B, we visited C, and we never visited E, we visited G. Actually, we didn't visit G, so we just discovered a new path to it, like a path to it from A. So right now, I'll start with the lowest cost, which is 20. That'll take me to H. So I'll visit H right now and try to get to other nodes from H. However, H is connected to no other nodes, so I'll just be copying the values again in H. 25A, 15 from F will take me to C, 40 from F will take me to D, infinity will take me to E, 15 from B will take me to F, 105 from A will take me to G, and 20 from C will take me to H. We visited H, we visited F, we visited C, and we visited B. And of course, we visited A since it was our starting point. So the lowest cost right now is 40 from F. That would take me to D. So currently I'll visit D and try to discover new paths to new nodes. So since we are currently in D, we want to actually discover new paths that would cost us less to get to other nodes. So one interesting node is G, since the only path to it we discovered up until now was costing 105 from the source point A. However, now we can actually get to G from D with only 35 points. But what is the lowest cost to actually get to D? So remember, we can get to D with 40 to F. So to get to D, A to D, it would cost me 40 from F. And to get to F, that would cost me 15 from B. However, to get to B, that would cost me 25 from A. So 40 plus 15 plus 25, that is basically 80. So A to D would cost me 80. So is 80 plus 35 better than 105? 80 plus 35 is 15. And of course 105 is way better deal than 115. So I'll just forget about that path. I'll keep the current path as is, because the new path, newly discovered, is basically more expensive. So nobody is interested in it. So I'll update G with 105A. And we can visit C, because this is double, it goes double directions for some reason. And we can get from D to C with 55. So we can get to D with 80 and get to C with 55. But what is the current cost from A to C? Well, to get to C, that would cost me 15 from F, and to get to F, we know that costs me 15 from B, and to get to B, it costs me 25 from A, so that's another 40. So the current cost to C is 40 plus 15, which is 55. So, is it better to get to D using 80 points and then travel from D to C using another 50 points, totaling 135? Or should I just get from A to C using 55 points? Of course, this is a better deal, so we will forget about the newly discovered path. So we will also update the C with the previously discovered path, because it turned out to be way better than the newly discovered one. And we will check other nodes. We can really get to nothing else but G and C from D. So we will just copy the current costs since we discovered nothing new. Remember, we visited H, F, C, and B, and A. And these are the lowest costs to get to them. Now, we will visit D, since this is the lowest cost. That will take us to the next unvisited node. And we would get to... We actually did visit D, and I didn't mark it. So now we're going to visit G. And let's circle it. We will take this path, and we'll travel to G, and start running the algorithm again from G. So I can get to A So I can get from G to A for 25 points, and I can get from G to pretty much nothing else. So the current cost to get to A is 0, since I already started at A, remember? Like, this is our starting point. So I don't need to get to G and get back to A to be at A, because this is already my starting point and I'm already at A without going through any of the paths. So of course I'm not taking this deal. 0 is way better than 25. So I'll just copy down the values again as is. We didn't discover anything new, nothing interesting. We'll just keep going. There is one point, however, that we never reached, which is E. So let's copy down the values. We visited those, we visited this, we visited this, we visited that, we visited that. It will cost me infinity to get to E. However, I'll take the infinity path and get to E. Since I got to E with infinity cost, I can't really get any better results than the current. So I'll just rewrite those into here, and that will be my final result using the algorithm, which is 25 from A would take me to B, and 15 from F would take me to C, 40 from F would take me to D, and infinity would take me to E. That's pretty much the best we got. And 15 from B would take me to F, 14 from, wait a second, 15 from B would take me to F, 105 from A would take me to G, and 20 from C would take me to H. As you can see, I visited all points, even E, and I updated my graph on each visit to get the better paths. And pretty much I got the result on my 7th run, since the E was unreachable, and the infinity is represented in your code as int max, for example. So that would never be less than any of the current paths discovered. So the last one would pretty much be useless, but you have to do it. And this is basically the basic explanation of the algorithm and how it runs. This was a directed weighted graph. We will run it in C++ after this video, and you can get a better idea on how to code Dijkstra's algorithm. Thank you.